Okay, let's talk about scientific notation. But before we do that, we need a little background information. And what we really want to review has to do with our base 10 and exponents first. So if we had 10 with an exponent of 5, we know that that means 10 times 10 times 10 times 10 times 10. When simplified, that is 100,000. And if you notice, the exponent is a 5, and we have 5 zeros in the number. If we had 10 to the 4th, that would be 10 times 10 times 10 times 10, which would be 10,000. Notice the 4 zeros. 10 to the 3rd would be 10 times 10 times 10, which would be, whoops, we don't need that, would be 1,000. 10 squared would be 10 times 10, which is 100. 10 to the 1st is just 110, which is just 10. And 10 to the 0 power, hopefully you remember anything to the power of 0 is 1. So this would be a 1. Now notice with these numbers, there's an imaginary decimal point, and it keeps moving to the left, doesn't it, as we go. We're reducing our number. It's getting smaller as the exponent got smaller. What happens if we have a negative exponent, like 10 to the negative 1st? Well, that would be the same as 1 over 10 to the 1st as a fraction, which is just 1 over 10. And as a decimal, that is just 1/10. If we had 10 to the negative 2, that would be 1 over 10 squared, which is 1 over 10 times 10, which is 1 over 100, which is 0.01. 10 to the negative 3 would be 1 over 10 cubed, which is 1 over 10 times 10 times 10, which is 1 over 1,000, and as a decimal, that's 0.001. 10 to the negative 4th would be 1 over 10 with an exponent of 4. So again, in fraction form, that's 1 over 10 times 10 times 10, 1 over 10,000, and as a decimal, 0.0001. And let's finish the pattern off with a negative 5. So 1 over 10 to the 5th, and that would be 1 over 10 times 10 times 10 times 10 times 10, one more, which would be 1 over 100,000, which is 0.00001. Now if you'll notice, the number keeps getting smaller and smaller, so as the negative increases, the decimal point keeps moving to the left and the number is getting smaller. So now, to move on to scientific notation, scientific notation is a short way to write long numbers. All right, so we could have a number that's a fairly long number, all right, and I would not want to have to repeatedly write that number with all those zeros. Now this number is fairly large. I have another number here, 0.000000042. Well, that's a long number, but it is a very small amount. But in science, we don't like to spend too much time writing all these zeros if we don't need to. So there is another way to write these numbers. This number written in scientific notation would be 4.65 times 10. And if we look back at this number, we have an imaginary decimal point here. And to get that decimal point here behind the 4, we have to move it 1, 2, 3, 4, 5, 6, 7, 8 decimal places, so this would be an 8. You always have a factor times a factor, where the second factor is your base 10 with an exponent. Now, if we think about it, 10 to the 8th is a large number, so 4.65 times that large number is going to result in increasing that. Now, this number here in scientific notation would be written as 4.2 times 10. Now, our decimal point is here. We have to get it behind the 4. The decimal point has to go to the right 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So my exponent would be a negative 8. So this here is scientific notation. These numbers here are written in what we call standard form. So this is standard form, and this is also standard form. These numbers down here are now written in scientific notation. So let's just kind of review again. Scientific notation has a very specific form. So it's always written as a factor times another factor, where the first factor only has one digit in the ones place, and following the decimal point are your non-zero numbers. No, in other words, no trailing zeros. And our second factor is always a 10 with some exponent. We always have to have a base 10 with an exponent as the second factor. So again, if we had the following number, we know that these here are called trailing zeros. And we don't want to keep writing those. So this would be written as 2.34 times 10. My imaginary decimal point was here. To get it, I have to get it behind the 2. So I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to move it 11 places, so that would be 10 to the 11th. Now, again, if I had a very small number with a number of zeros, I have to get this decimal point back behind the 4 so that I could write my first factor as a 4.16. My second factor is 10. I just need to figure out what my exponent is. And I had to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So this would be a negative 8 in the exponent. All right, so we wrote these numbers first in standard form and then wrote them in scientific notation. Well, what if they give us scientific notation? For example, if we have 3.401 times 10 to the 5th power. 10 to the 5th power we know is 100,000. And so we're really taking this number and multiplying it by a larger number. But the exponent is the shortcut. It just tells us how many places we have to move the decimal point. So I'm going to put my 3, 4, my 0, 1. And I'm going to move my decimal point 5 places. So it was here, so I'm moving it 1, 2, 3, 4, 5. And what would I do with these two positions here? The ones below, I would put zeros. So my new number would be 340,100. Go back and put my commas in, so that would be 340,100. If I had, let's do problem number 1. Problem number 2. If I had, 0, we're going to fix that, excuse me. We're going to change that to a 9.4 times 10 to the negative 5th. And 10 to the negative fifth is 1 over 100,000, a very small number. So this negative 5 means I'm taking this number, I'm multiplying it by a small number. So that means the decimal point is going to have to be going to the left to make the number smaller. So I'm going to put my 9 and my 4 down here. The negative 5 tells me I'm moving the decimal point 5 places to the left. So it was here, so I'm going 1, 2, 3, 4, 5. My new decimal point will be there, and I will have to fill these places in with zeros. So now my new number, 9.4 times 10 to the negative fifth, would be 0.000094. All right, and let's just try one more number with the decimal point. Let's see if we have 8.05 times 10 to the negative 1. This just tells me I'm moving the decimal point one place to the left. So if I put my numbers down, my decimal point was here, I'm moving it there. So in scientific notation, this would now be 0.805, 805 thousandths. All right, thanks so much. Have a good day.